All right, we're supposed to find all the second partial derivatives of this function here. So these are partial derivatives, multivariable function. So let's start out with, now we're doing second partial, so in order to do second ones, we need to start out with doing f sub x of xy and f sub y of xy. So f sub x first. This is an exponential function, so in order to take the derivative, I take the derivative of the power with respect to the variable that I'm working with, times the original exponential function, just following the rule from Calculus 1. So when I take the partial with respect to x of this guy, again, you think of the other letter other than x to be a constant. So I'm going to take the derivative of x times y, where y is a constant. So that derivative turns out just to be y. And then times e to the xy. Now I'm going to do the partial with respect to y of e to the xy. I don't know why I changed notation there, but it's okay. So again, if I use the same method as before, I take the partial with respect to y of xy, the power, times the original exponential function. Again, this is with respect to y, so x is a constant. So I take the derivative of a constant times a variable. I use a power rule on the variable, so it's just going to be x, derivative of that with respect to y, e to the xy. That's the first derivatives. Now we're going to work on the second partial derivative. So lining up over here, I'm going to do the derivative of this guy now with respect to x again. So now y is a constant, so I can kind of pull the constant out and then just take the partial with respect to x of e to the xy. Well, I already know the partial with respect to x of e to the xy. That's what this is, right? So that's this y comes down, and then this derivative here is the same as it is up here. So y e to the xy. And then to simplify, y squared e to the xy. Continuing over here, I'm going to take the partial of y and take the derivative of it with respect to y. So that means that x is a constant. I can take it out. I'm going to take the partial with respect to y of e to the xy. Well, that's exactly what this is. So this is going to equal x, and then the derivative of this is the same, times x e to the xy. So that's equal to x squared e to the xy. Now there's one more that I have to do. So I want to do f sub xy. Now I know that there's f sub xy and f sub yx as well, but we know that those two are equal, so I just have to do one of them. So f sub xy, I have to take the derivative with respect to y of f sub x. So f sub x was defined as y e to the xy, and I'm going to take the derivative of that guy with respect to y this time instead of x. So in order to take this derivative, I have to actually use the product rule now, because this is y, the independent variable, times another function with the same independent variable in it. So this is going to be the derivative of this first function with respect to y times the second function, plus the first function times the derivative with respect to y of the second function. So earlier, we took the derivative with respect to y of e to the xy. That's going to be the derivative with respect to y of xy to the power times e to the xy using the rules of derivatives. So e to the xy plus y, the derivative of this guy with respect to y is just x, e to the xy, and there's your second derivative, f sub xy. Now, I don't have to do this guy here because I know that these two things are equal, so f sub yx is also the same function as f sub xy.